Welcome to Study Loop.
So in this problem, we have a window made of glass, and they want to know at what height the heat is being lost through the window. So we have all the information here. So the outside temperature is minus 20 degrees and inside temperature is 90.5 degrees. We have the thermal conductivity of the glass here and the thickness of it. So to find the heat flow, we just need to write the rate flow equation. Ka delta T over delta L. And we have all the information that we need to find this. So substituting here, remember to convert millimeters to meters. So in this case, this will be 5.2 times 10 cube meters minus 3. And then the heat flow will be just 2.1 times 10 to the 4 watts. Now, in the second item, you put an additional layer of paper now, so they give you the thermal conductivity of the paper, so kappa of the paper. This will be 0.0500 watts by meters Kelvin. And you have a new thickness now, the thickness of the paper. Let's call this LP. And this is 0.750 millimeters. Now, with this information here, we can calculate the heat flow through everything. Now we have two layers. It is better to find the total thermal resistance of this object and then calculate the heat flow directly using that the heat flow is A delta T divided by the total thermal resistance, total. And what is this R resistance? The thermal resistance R in general. So let's move this. Let's write it again. R is equal to L, delta L, divided by the thermal conductivity. So we can calculate this for each one. So we have delta L of the glass being 520 millimeters and kappa of the glass being 0.8, and for the paper as well. So doing this, we obtain that let's put this up. So let's move this up here. So the R total is R of the paper plus R of the glass. Just substitute the values here and we obtain 0.0215 meters square Kelvin by watts. Now with R total, we can find the heat flow of passing through everything. So let's find this. So let's open a new one, and the heat flow passing through everything is just the area delta T divided by RT. And we assume that both the temperature stay the same. The only thing that changes is RT. So the difference in temperature is still the same one as here. And this give us, so let's write this. This give us 6.4 times 10 to the 3 watts, 6.4 times 10 to the 3 watts. And we can see that the layer of paper decreases the heat loss by a factor of 3, because we can compare it to the other heat that we obtain here. So we have here 2.1 times 10 to the 4. So just putting a sheet of paper isolates a lot the interior.